Hello, welcome. I am the Vice President of Infrastructure Engineering at the Gilt Group. And, but you can also call me the Vice President of Empowerment and Innovation. Let me talk about that for a second. What makes me say that is that when you have not a very good infrastructure in the company, then you will see that the site goes down when you change it, or sometimes it goes down even when you don't change it. And then people are afraid to touch it, and they create like a lot of silos and approvals and processes to make sure that you cannot touch it. And that in general makes people unhappy. So you can compare that to a place where the site is up and running always, very stable, people change it every day, maybe even multiple times an hour, and that's actually a very, very happy place. And that is the place that we have at Gilt, but we are constantly looking for ways to improve it. And so I want to talk about this today a little bit here. You might wonder what that has to do with this thing here behind me. And you can either say it's empowerment and innovation chasing each other, and reinforcing each other constantly. Or you can just say it has nothing to do with what I just explained, and I just wanted to show off that I can present animated GIFs too. So the three things that I'm very, very passionate about and that I want to talk about today is the Gilt Group as such. I want to talk about immutable deployment platforms and continuous delivery, and want to talk about how this is helping us to create this better place. I'm going to segment the talk into kind of three things. I want to a little bit talk about why we're doing this. I want to show the architecture, how does it look like, and at the end I want to talk a little bit about the implementation. Just from a terminology point of view, you will hear me talking about the Iron Cannon. The Iron Cannon is our continuous delivery and continuous deployment platform. And you will hear me talking about the software provisioning and hardware provisioning platform, and the code name for that is Galactica. The first version that we built, we have learned a lot in the last couple of years. The first version that we built was called Mothership, and but we decided that we want to upgrade that to a Battlestar, so we called it Galactica. Let's first talk a little bit about the Gilt Group, just by show of hands. Who knows the Gilt Group? Wow, awesome. I multiply that by 2, because if you know it, then at least one other person in your life knows it too. So the Gilt Group is an e-commerce company, and we sell very well-known designer brands at a discount. And we can do that because we buy excess stock from these very well-known brands. And sometimes we even sell cars. Cars like this are less of a problem. If you ask me, my biggest problem are shoes. When we have a Louboutin sale, the shoes with the red sole, that's a very interesting day on the site. I will talk about that in a minute a little bit more. Just from a numbers point of view, the Gilt Group is 6 years old. We started like with $1 million a quarter 6 years ago. This year we will make $750 million. We have 150 developers. We have 10 system engineers. The interesting thing is about our business model, as you might know, is we send you an email and tell you that tomorrow one of our sales campaigns will go live at noon Eastern Standard Time. And at that time, all of the 6 million members rush in and try to get whatever they want. And that means every day between noon and 1 o'clock Eastern Standard Time, we, on average, make $1 million. But on a good day, we make $1 million in 18 minutes. And that's actually a very nice race. So that's our record. The Christmas season, or the season is coming up. We're probably going to beat that in the season. One thing that comes out of that business model is this is our traffic profile. So one thing that we have to deal with is extreme scalability. And maybe to show this here, this is like the first, I think, 7 seconds at noon with a density profile of the response time. And you can see that within 7 seconds, actually the response time on the side kind of swings back to under 1 second. And this is where we want to be. Yeah? The interesting thing is this is about the hardware, this is about the software. But when I'm talking about continuous delivery and immutable deployment platforms, I'm also and mainly talk about scalability from an organizational point of view. How can you make sure that you have 150 developers and they can get shit done independently from each other? Yeah? So immutable deployments help with that mainly. Let's talk about the Trinity. 18 months ago, we decided that we have to do something about this in terms of how to scale the organization, how to scale from a hardware point of view or from a software point of view, and we decided to build the Trinity, not that one, but this one, the Trinity of infrastructure engineering, which is a combination of technical ops, traditional tech ops if you want, DevOps, and performance engineering. And we decided that it would be a good idea to put an engineer in charge of that, mainly me. I'm the oldest member of Gilt Tech who writes Scala source code. The mission of that group is we are in charge to build and run infrastructure that will allow Gilt to deliver on a 100% uptime record, while allow Gilt to innovate and iterate at the highest rate possible, and do all of that as cost-effective as possible. I call this the CAP theorem of infrastructure engineering. The reason is to get 2 out of the 3 is kind of easy, but to get all 3 is close to impossible. So it's a very good challenge. My name is Roland. I'm actually from Dublin in Ireland. So Gilt has the main software engineering site in New York, but we also have a software development center in Dublin that has grown from 1 engineer, me, 2.5 years ago, to by the end of the year, we will probably have 25 people there. One other thing is, I'm not sure if you've seen it, yeah, but 2 weeks ago, Jim Carrey, the comedian, released a book called Roland Rolls. So apparently, I'm also a wave. So if you want to know more about that, then we can talk afterwards. So the first thing is, why do we do this? Why do we do this why is Gilt doing this? The main motivation is we are growing very, very fast. Yeah, we have been growing, we will continue to grow. And while we are growing, we need to make sure that we maintain or maybe even improve our ability to innovate. And we need to maintain our velocity of innovation. So how can you get that done? There are obviously a lot of things that you need to do to make that work, but 2 key ingredients that we are very, very passionate about at Gilt is empowerment of people and decentralization, so that people can work independently. From an infrastructure engineering point of view, we have this mantra of all ops and 0 waiting. And to maybe explain that, how this is supporting empowerment, for instance, we had a talk from Kate in the morning in the keynote, and she was talking about like no managers versus all managers, basically saying that we should be all managers to determine our future and manage ourselves. The same is true here. This is why we don't call it no ops, we actually call it all ops. Means the end point of this is that everybody in the Gilt engineering organization feels confident to do operation himself or herself. Yeah? And that will actually create a very interesting situation where there is no waiting, 0 waiting. You don't wait on anything, you don't wait on anybody. Yeah? You just can get things done and can get things into production. So with that goal in mind, yeah, the question was, how can we create something that makes that happen, but maintain like the manageability of it and maintain the upside? Yeah? So what you can do easily is you can just give everybody access to production, but my prediction is it's not going to do you any good with respect to your uptime. Yeah? So you need to find a way to make that happen in a way so that it's not hurting your uptime. So we did what we learned on the first day, or what we learned yesterday: good architects don't borrow, good architects steal. So we started to steal. And so who knows who that is? Maybe back there? Yeah, that's Rich Hickey. Yeah? Rich Hickey is the creator and father of Clojure. Clojure is a functional programming language. Before I joined Gilt, Clojure was my favorite programming language. And, but it's not only Rich Hickey, let's say basically everybody, Martin Odetsky, the guy that is behind Scala, everybody who, all of the functional programming languages are big in immutability. Yeah? So they have immutable data structures, and they have side effect-free functions. And with that, a whole slew of problems that you normally have in terms of writing concurrent programs, doing testing, and so on, become much smaller or just disappear. Yeah? So from a history point of view, Gilt started 6 years ago, first LAMP stack, but then very, very fast, very soon, there was a Ruby on Rails implementation, 20 engineers, 20 servers, worked for a while, but at the end, Ruby as a language reached its limits from a scalability point of view, let's say both technically and also from an organizational point of view. And so 2 years ago, we had a situation where we had 150 engineers, 150 servers, and the stuff was mainly Java-based. Yeah? And at that point in time, we actually adopted Scala, yeah, as the programming language of choice for all our new development. And that had an unbelievable impact on our productivity. Yeah? So by now, all of the new development is in Scala, and Gilt is mainly a Scala shop. A year ago, we suddenly had problems in production where the mutable aspect of our production environment created problems for us, where configuration changes either did not work as expected or were only rolled out, like say, partially, and then all hell broke loose, or let's say we had near outages, and so it was not a good situation, and we started to take a look at it, and we said, why don't we steal this concept of immutability for server deployment? Yeah? How would an environment where the entire server configuration and service configuration is immutable, how would that look like? Yeah? So you never really update anything anymore. You only create new service instances and you delete old ones, and the same is true for servers. And that was the time when we created the project that I'm talking about. This is the time when we created Galactica. So the question is, why is this taking off right now? Yeah, so there is, from my point of view, like an internal reason inside Gilt, like a little bit of pressure to get this done. And there's an external reason that I will talk about on the next slide. The internal reason is, there is something interesting about this slide. I'm not sure if you can see it, probably not from the back. So let me help you a little bit. If I put like 2 straight lines on it and a little bit of a round dot, then you can see that in the first quarter of 2012, the number of services that we have in Gilt started to increase. And that is caused by the adoption of Scala as maybe one reason, but the other thing is, at that point in time, we were thinking about how can we accelerate our software engineering even further. And the idea was that we adopt something that we call LOSA, lots of small applications for web applications, and a microservices architecture for our backend services. So we said we have to make it much, much smaller so that every engineer can kind of work on something independently from the other guys. Yeah? And this has accelerated our software engineering dramatically. So with that, we are on a good trajectory, but the question is, how do you put all of that into production? Yeah? How can you make sure that in production you can roll these services out and you don't get into a configuration hell. And that is what we try to, let's say, do with Galactica and the immutability, or the immutability that is in Galactica. Another thing is, just from a timing point of view, the time is right now to actually think about it, talk about it, and implement something like this for another reason. When we started to think about this a year ago, we looked at the available options. And one thing is, if you want to do this right, then let's say my opinion is what you have to do is you have to make the containers as small as possible. Basically, at the end, you need to find a way to deploy one service per container. Yeah? Basically, wrap the service in a container so that it becomes easy to deploy and that there are, let's say, no dependencies beyond the service that is in the container. And so we looked at the options. So we looked at KVM, and we looked at OpenVZ, and a couple of other things. We looked at OpenStack, and quite frankly, for our purposes, all of that stuff was just too heavy. Yeah? Either too heavy to manage, or too heavy to run, or bad performance, so it did not really work. 9 months ago, we found like the first kind of hint on a winner, and the winner was Linux containers. That's lightweight, and you can deploy hundreds of them on a box, so that works maybe well. And then we looked for a way to manage it, and that was Apache Cloud Stack. But in the meantime, a lot of people have started to think about this even more, and I'm not sure who knows this, but here in San Francisco, there's actually a company or an open source project that's called Docker.io. Show of hands, who knows Docker.io? Yeah, half of the room. I predict when we come back next year and have FutureStack worldwide, either in Dublin or in Berlin. Hint, hint, hint. I would assume that, let's say, the entire room, the arms go up and everybody knows Docker. Yeah? It's actually a wrapper around the Linux container and makes the Linux container even more self-contained and manageable and deployable and configurable. So with that, I just want to move on and want to talk a little bit about what we do actually and what we have done so far. So Galactica right now is kind of half done, and I think that, let's say, we have done initial rollouts, but let's say the real impact will show in the next 6 months. The Gilt architecture is not surprisingly looks like this. I'm not sure if you can read this, but it has like a front-end tier. Front-end tier is web, API, and mobile. And then we have a couple of load balancers, SUSE in our case, and we talk to web applications. They talked through a service load balancer to our service layer. Service layer is by now mainly Scala, REST, and JSON. And then we have a couple of databases, Postgres, MongoDB, and Voldemort. So that's our stack. Obviously, we have a little bit of secret sauce in it to make sure that we can survive noon. The Galactica architecture is very simple. Galactica architecture has two components, two main components. There is a hardware provisioning piece and a software provisioning piece, and the two kind of communicate through each other through the abstraction of a compute node. Yeah? So the hardware provisioning piece is responsible to get the compute nodes up, and the software provisioning piece is responsible to fill the compute nodes with containers and make sure that everything is utilized in the best possible way. From the top, the entire thing gets triggered by our continuous delivery and deployment platform, by the Iron Cannon, which will basically tell the software provisioning piece to put something into production. Let me maybe talk about the hardware provisioning on this slide, and then I have one more slide to talk about the software provisioning in more detail. But just from a hardware provisioning point of view, it's actually a very interesting piece of software in the sense that it's doing two things very well. The first thing that it's doing very well is it actually tries to make hardware useful. Yeah? And that means if we get a new piece of hardware into our data center, the first thing and the only thing that we actually do is we give that piece of hardware a LOM IP, a lights out management IP address, yeah? And we kind of tell the hardware provisioning piece of Galactica that this piece of hardware exists and this is the LOM IP. We don't need to do anything else. Galactica, the hardware provisioning piece, will actually go to the LOM IP, will extract all of the hardware profile from the hardware, will put it into the Galactica database, and will start to move this box towards the status of up, yeah, basically, so that the thing turns into a compute node. So the next thing is we get an IP address. When we have the IP address, we talk to Coupler. We basically boot the box. When the box is up, we do something else. We talk to Puppet, and we configure the box so that everything that the box needs to be a compute node is there. And then we basically tell the resource allocation service on the software provisioning side that there is new capacity available to deploy something to. I want to point something out here, and that is Puppet. And I want to point out that we have been a big, heavy Puppet user for a long time. But as I mentioned earlier, either due to our own incapabilities or whatever unawareness, let's say we always had problems to get this right. Yeah? So my belief is that we are better off to use Puppet as a configuration tool, yeah, where it runs once, puts all of the software that is needed onto the box, and then we stop Puppet from running, yeah, and the box from there on is immutable. Yeah? And if I need a configuration change, I will make the change in Puppet, will change the configuration of this, but then I boot up a new box, yeah, and get something up and running from scratch. That kind of leads me to the scenario that I want to talk about in terms of how does a hardware upgrade look like, or a configuration change look like. Configuration change on the hardware side means we make the configuration change, we get a new piece of hardware, we boot it up from scratch, we relocate all of the services if we want to or have to, and then we shut down the old stuff. And that is both true for hardware changes and software changes on the hardware side. Let me maybe talk you through one more picture here on the, or one more slide here on the software side, because I've talked about this immutability thing a lot now. Let's say in the easy way to think about it and the easy way to talk about it is everybody knows CRUD, yeah? Create, retrieve, update, and delete. And immutability just means that you do only create and delete. You never update, and in between you retrieve or use it, but you never update it. So how does that look like for a service? Let's say I want to make either I want to deploy a new version of a service or want to make a configuration change to a service. How does that look like? So in our case, a year ago, 18 months ago, the configuration of the service was outside the service deployment and was managed through Puppet. In the meantime, we have changed this. All of the configuration of the service is actually in the build artifact in the RPM that this service version is built from. And that means what happens is the user talks to the ion cannon and says, I want this configuration change or this new version of the service deployed. The ion cannon is building a new, is building the service, is building a new Docker image for that service. It then talks to the software provisioning piece and says, deploy this server image. The server provisioning piece talks to the resource allocation piece and finds space somewhere. Finding space somewhere is actually a very interesting problem because you want to make sure that the space is on different servers. And I talked about the earlier step where we investigate where the hardware is, and so we also know which rack the server is in. So we want to make sure it's not only different servers, but the servers are also all in different racks, so that we can use a complete rack without using the service. So this finding space thing is a very nice problem and a very nice algorithm. The next thing is, after we have the space, we talk to the, container service and say, please deploy all of these images onto these compute nodes. Afterwards, we talk to the load balancer and say, hey, look over there. There are 3 new instances. Please start to dispatch traffic to it. Then we do a health check on it. And if everything is fine, we can then go and talk to the load balancer, take the old instances offline, and delete them. And after we have deleted them, we kind of reclaim the space and tell the resource allocation service that there is space available on a couple of nodes that have just lost a couple of images. So, and then we report back. The interesting thing is there is no update here. It's all create and delete, no update. It's always roll forward. That's maybe another way how you can use the picture, how you can use the dominoes. Just think about it. Create and delete, it's roll forward. One other thing that has come up recently, how we use this in a very effective way, is for our staging. And we are in the middle of developing this. And staging has been a very interesting challenge. Another maybe quick survey, show of hands. Who's struggling to get staging up and running and staging right? Aha, half of the room has the hands up, the other half is lying. So what we have done here is with this concept of immutability, and I'm not sure if you can visualize this or if you know it. When you do this immutability thing from a data structure point of view, all of the implementations do something that is called copy on write. Yeah? So when you have these immutable data types, yeah, and you want to change them, you need to copy them. Yeah? But copy is a very expensive operation. And so when you basically do a change to an immutable data structure like a large tree or so, it's not really copied. What happens is under the hood is that only the piece that you have changed gets copied. And under the hood, the programming language will still use some of the original data structure. And we are going to use that kind of thinking here to build staging environments very easily. We have this concept of a pod. And the pod actually gets created and is kind of a lens into an existing environment, into a root environment. Yeah? In our case, it's called stage 51, or let's say that's actually our integration environment. And then you have this lens into this environment, and then you can make like a copy on write, means you can say, okay, now deploy only this one service into this pod, yeah? And it will hide the service that is in integration. And that will give you a very flexible staging environment. So that's another use of what we do with respect to immutability. Let me kind of wrap up with a thought. And the thought here is twofold. The first thought is there is right now a lot of talk about continuous delivery, continuous deployment, and today we have talked about immutable deployment platforms. Yeah? All goodness. What's happening is that with this, you will get much more deployments per day or per hour. Yeah? And that is a blessing in disguise, because all of these deployments actually create a lot of data. Yeah? And that is actually something that you want. Yeah? Because what you really want is you want to do all of these deployments, and then you want a feedback loop, yeah, that actually tells you how good or effective your deployments are. And you can put data into that feedback loop. For instance, you can put A/B testing data into that feedback loop. You can put, let's say, performance data into that feedback loop. You can put other data into it. For instance, you could maybe even crawl your production environment and could report back if reality is actually in sync with what you think is in production. So lots of interesting ways how you can actually create this feedback loop or enrich the feedback loop. So I think my first point is, if you have not thought about it yet, I think it's a good idea to think about how not only to put something into production and deploy it, but also how to create this feedback loop, yeah, and basically report back on the quality and the value of your deployments. Now, the next thing is, if you do this a lot, suddenly there is a lot of data, yeah? And that means a manual approach to look at all of this data, yeah, is probably not going to make you happy. Yeah? It's just going to be too much. You will have cohorts of people sitting in front of screens looking at A/B testing data or performance data or whatever else. So you need something. You have fully automated continuous deployments, and that means you probably need something like fully automated continuous analysis on the way back. Yeah? And I just want to maybe make one example here for how this could look like. And this is something that we are working on right now. For our load and performance testing, because we have a lot of deployments every day, we have built like a totally automated load and performance testing framework. It's based on Gatling. And the Gatling thing, let's say, runs multiple times a day and creates interesting load and performance testing data. Sometimes we look at it, let's say, with New Relic, yeah, with the GUI, with the user interface. But most of the time, so far, or let's say by now, we have started to do something else. And that is, we have a process that we call a data reaper. And that data reaper actually gets data from the Gatling test, from New Relic, and a couple of other sources, and puts this data into a Mongo database, yeah? So that we have snapshots of these load tests. And then we put something on top of it that we call the smoking gun detector. And that smoking gun detector is comparing the data that we have just collected against a known good state. The known good state can be yesterday, or it can be, let's say, a good sales campaign or a good fingerprint that we have collected a couple of weeks ago. Yeah? And then the smoking gun detector will just tell us, OK, that looks good, ignore it, or maybe here is something wrong. Now a human being needs to take a look at it. And that filter is incredibly valuable. So just maybe to summarize and to wrap up, Gilt is right now investing to build a continuous delivery, continuous deployment platform. We are investing to build an immutable hardware software provisioning platform and complement this with continuous analysis capabilities to continuously assess the results of the deployments. And it is my belief, yeah, that getting this done, and we are 50% done, yeah, but getting this done and getting this in place, yeah, will help us to make Gilt a place where we have even more empowerment and even more innovation than we have today. Thanks.